Hi, in the following video, I will solve this problem out of total of 3. The problem says that we have a container and with a weight of 1155 newtons. And we are asked to find the magnitude of the vector P and the angle between the vector P and the vector or the force and AD. This is the angle alpha. Well, the first thing that I'm going to do is find the coordinates of the points A, B, C, and D. A is in 0 in X, minus 600 in Y, and 0 in Z. The point B is in 450 in X direction, 0 in Y direction, and 0 in Z direction. The point C is in 0 in X, 0 in Y, and minus 320. And the point D is in minus 500 in X, 0 in Y, and 360 in Z direction. Well, once the coordinates of the points have been found, the next thing that I'm going to do is find the vectors position. Well, the position vectors, sorry. The position vectors. The first position vector is the vector AB. The next is the vector AC. In the last is AD. Well, and to get the position vector, this position vector, and we only need to subtract and the coordinates of the point B minus the coordinates of the point A. That is 450 0 0 minus 0 minus 600 0. That is equal to 450 I plus 600 J, and that's it. Millimeters. In the following position vector, I'm going to subtract the coordinates of the point C, that is 0 0 and minus 320 minus 0 minus 600 0. That is equal to 0 in Y, 0 in I, 600 j and minus 320 k millimeters. And for the last position vector, we only need to subtract the coordinates of the point D, that is minus 500, 0, 360, minus the coordinates of the point A, that is 0, minus 600, 0. And this is minus 500i plus 600j plus 360k millimeters. Well, once the position vectors have been found, the next step is calculate its respective magnitude. For the first position vector is RAB, that is square root of plus 600 square. For the next, square root of 600 square plus 320 square. And for the last is AD equal to square root of 500 square plus 600 square plus 360 square. And now I'm going to use the calculator to calculate the values. For the first is 400 square plus 600 square root 750. For the next is 600 square plus 320 square root 680 and 80. And for the last is 500 square plus 600 square plus 360 square, all in square root, that is 860. Well, the next step is find the respective unit vector for each vector. The first unit vector is the unit vector AB. The next AC, and the last AD. Well, the first to find the unit vector, and the only thing that I need to do is divide 1 over its magnitude, that is 650, times its respective vector, that is 450i plus 600j. For the next is 1 over 680 times its respective vector, that is 600j minus 320k. For the last is 1 over 860 times its vector, that is minus 500i plus 600j and j plus 360k. And the results are, for the first is 450 over 750, 3 over 5 I plus 4 over 5 j. For the next is 600 over 680, that is 15 over 17 j minus 8 over 17k. And for the last is 500 over 860, that is 25 over 43 I negative plus 30 over 43 j plus 18 over 43k. Well, to find now the next and the following step is transform these unit vectors into force vectors. To transform these unit vectors into force vectors, the only need that I need to do is multiply each unit vector by its respective magnitude. Well, as we can see, and here we have a pulley, and this is a force and with a magnitude of P. Since this is a pulley, this force is the same in this cable. For that, we can say that the magnitude of this force is P. Now I'm going to proceed to transform the unit vectors into force vectors. The first force vector is force AB. The following is the force AC. In the last, the force AD. Its magnitude, that is AB, multiplied by its respective unit vector, that is 3 over 5 I plus 4 over 5 j. For the next is AC times its respective unit vector, that is 15 over 17j minus 8 over 17k. In the last is its magnitude is p times its respective unit vector, that is negative 25 over 43 I plus 30 over 43 j plus 18 over 43 k. Well, now I'm going to continue this procedure the next page. Well, uh, here we are again. Well, the next step the next step that I'm going to do is multiply the magnitude of each force and by each component in each force. For the first force vector, it is going to be 3 over 5 the magnitude of the force I plus 4 over 5 the magnitude J. For the next is the force AC, that is 15 over 17 times the force AC J minus 8 over 17 the force AC K. In the next is the force AD, that is minus 25 over 43 P I plus, well, I'm going to check this value. Yeah, here is 43, 30 over 43 Pj plus 18 over 43 Pk. Well, for the first law for the first Newton's law says that this system is in equilibrium. The sum of all the forces included and must be 0. So the last force that we need to add here is the weight of the container. That is W equal minus 1155 J. The sum of each component for all these forces must be 0. So the first thing that I'm going to do is sum each components. The first is going to be the components in terms of I, that is 3 over 5 the magnitude of the force AB minus 25 over 43B equal to 0. In the next, for the components in terms of J is 4 over 5 the force AB plus 15 over 17 the force AC plus 30 over 43 B minus 1155 equal to 0. In the last ones are the terms of K, that is minus 8 over 17 the force AC plus 18 over 43 P equal to 0. Well, as we can see, we can solve in this first equation and this variable, and here we can solve for this variable. We can replace them into the second equation. Well, the first 3 over 5 the force AB is equal to 25 over 43P, that is the force AB equal to 5 over 3 times 25 over 43P. In the equation in terms of K, we have 8 minus 8 over 17 the force AC equal to minus 18 over 43 B, that is the force AC equal to 17 over 8 times 18 over 43 P. Well, now we only need to replace them into the second equation, that is 4 over 5 the force AB, that is 5 over 3 times 25 over 43 P plus 15 over 17 times the force AC, that is 17 over 8 times 18 over 43 P plus 30 over 43 P equal 1155. Well, here we can we have as a common factor and the variable P, and we can out this variable and cancel here, and that's it. Well, P times 25 over 43 plus 15 over 8 times 18 over 43 plus 30 over 43 equal 1155. This is equal to all of this, and for calculate uh, this operation I'm going to use a calculator. 25 over 43 plus 15 over 8 times 18 over 43 plus 30 over 43. That is 2.064 equal 1155, and for that P is equal to 560 newtons. This is the magnitude of the force P. Well, once we have the value of P, we can say that that this vector is and once we have the value of P, and we can say that this vector is, I'm going to use another page, the vector P is equal to minus 560 J newtons. And the only thing I have to do is to invert the components of this vector, of this vector AD, invert its components so that it's directed in this direction, and I can draw it as follows. As the force vector AD is equal to minus 25 over 43 pi plus 30 over 43 pj plus 18 over 43 p Okay, now we only need to replace the value of the force P, that is 560, to get the correct expression of this vector. This minus 25 over 43 times 560 minus 325.6 I plus 30 over 43 times 560, 390.7J plus 234.4K. Well, and to get this force dA, we only need to invert each component. That is 325.6 I minus 390.7 J minus 234.4 K. Well, once we have this expression, we can draw it, or we can represent the force P, and this force as shown in this drawing. Well, we know that the dot product is the dot product of the force P dA equal to the magnitude of the force P times the magnitude of the force dA cosine of the angle. Well, we have these vectors and the magnitude of P. The only thing that it's missing is the magnitude of this vector, that is f dA well, we know it is equal to P. For that, we only need to do the dot product, and this is the vector P, that is 0 minus 560, 0, dot product in this vector is 325.6 minus 390.7 minus 234.4, that is equal to 560, 560 again, and cosine of alpha. Well, to get the dot product, we only need to multiply in this way. And as we can see, both of these products are going to be 0. So the only product that we need to do is minus 560 times minus 390.7 equal to 560 times 560 times cosine of alpha. Here minus time minus is positive, and we can cancel this expression that is in both sides of the equation, and we need to solve for cosine, and cosine is equal to 390.7 over 560, and the angle alpha is equal to arco cosine of 390.7 over 560, and this is equal to 390.7 over 560 arc cosine 45.76 degrees. The angle between the force and AD and the force P is 45.76 degrees. This is the second problem that I'm going to solve, and this problem says that a portion of mechanical coins and sorter works as follows. Pennies and dimes and roll down the 20 degrees inclined. The last triangular portion of which pivots freely about the horizontal axis through and the point O. Dimes are light enough, 2.28 grams each, so that the triangular portion remains stationary and the dimes roll into the right collection column. Pennies, on the other hand, are heavy enough, 3.06 grams each, so that the triangular portion pivots clockwise, and the pennies roll into the left collection column. Determine the moment about the point O of the weight of the penny with S equal to 9.05 millimeters with 3 different methods. The first method is using the perpendicular distance to the force line action. So, since we have an object with mass, then the weight or the vector of the weight is in y negative direction and negative y direction. So its line action is this. Is this line. So the first thing that we need to find, the first thing is to find the total weight of the penny. We know that the mass is equal to 3.06 grams. So to find the total weight, we need to transform this mass into kilograms, from grams to kilograms. So to do that, we only need to multiply by a conversion, that is 1,000 grams is equal to 1 kilogram. So the mass is equal to 3.06 times 10 power minus 3 or negative 3 kilograms. Now, as we can see, here is the line action of the force or of the weight. So now we need to find the perpendicular distance that is this. Well, to find this side or this measure, we need to see that if we draw a line, a parallel line like this that passes through the point P, we get this line. And as we can see, here we have triangles, and here we have this angle that is 20 degrees, is the same, and right over here, 20 degrees, that is the same angle in this side, in this part of this triangle, 20 degrees. And for that, we can say that this angle is 20 degrees. So for that, we can say that this angle is 70 degrees, and here we have another triangle. Yeah. Here we have two triangles in which we need to find this distance that I'm going to call x1, and this another distance that I'm going to call x2. And the sum of these two magnitude is going to be the perpendicular distance to the line of force. So the first variable is x1 is going to be here we have a triangle. This length is the same as this. This is the S, and the distance S, that is 9.05 millimeters, and here we have 9.05 millimeters. So as we can see, the hypotenuse of this triangle is 9.05 millimeters. So, and here we have 20 degrees, and therefore this side is going to be the hypotenuse times cosine of 20 degrees. 9.05 millimeters times cosine of 20 degrees. And x2, to find x2, we need to realize that here we have another triangle in which this side of the triangle is the same as this. It's the same like this, that is 3.5 plus 9 plus 9.5, 3.5 plus 9.5, that is 13 millimeters. So this distance is the hypotenuse, and here we need to find the side. And this side is going to be the hypotenuse times cosine of 70 degrees. That is going to be 13 millimeters times cosine of 70 degrees, and therefore the length x, that is going to be x1 plus x2, is equal to the sum of these operations, that is 9.05 times cosine of 20 plus 13 times cosine of 70, this 12.95 millimeters. Well, so far we have the perpendicular distance, and the weight is equal to the mass, that is 3.06 times 10 power minus 3 kilograms times the gravity. I'm going to use the gravity as 9.81 meters over seconds square. So the momentum around the point O is going to be x times the weight, that is 12.95 millimeters times the weight, that is 3.06 times 10 power minus 3 times the gravity, that is 9.81, and the moment around the point O is going to be 12.95 times 3.06 times 10 power minus 3 times 9.81. The moment is 0.3887, that is approximate 0.39 newtons millimeters, and clockwise direction. Now I'm going to explain, I'm going to solve this problem and by using the part B that says that we need to find the moment about the point O by using the components of the force. The force is the weight, is the vector weight of the penny. So as we can see, this force, and we can transform this force into two forces, and one force that is perpendicular to the inclined plane, that I'm going to call W perpendicular, and this another in this direction is parallel to the plane, to the inclined plane, that I'm going to call W parallel. So, and as we can see, and here we have an angle of 20 degrees, and here we have an angle, a right angle. This is a right triangle, and this part of the triangle, that is W parallel, is the opposite of the angle. Therefore, the side is the weight times sine of 20 degrees. Well, the weight is 3.06 times 10 power negative 3 times the gravity times sine of 20 degrees. And the component that is perpendicular to the inclined plane is the opposite of the inverse of the sine. No, actually no, not the inverse. So as we can see, this side of the triangle is not opposite, the adjacent side. Then this side is the weight, that is 3.06 times 10 power negative 3 times gravity cosine of 20 degrees. As we can see, here we have then two moments. Well, the total moment about the point O is going to be W parallel multiplied by its perpendicular respective distance, that is 3.5 plus 9.5, that is 13 times 3.06 times 10 power negative 3, the gravity, that is 9.81 sine of 20 degrees, plus another moment that is using the perpendicular W, that is 3.06 times 10 power negative 3 times the gravity times cosine of 20 degrees times its perpendicular side, that is this another one, 9.05. Finally, the moment about 0 is, I'm going to use the calculator, 13 times 3.06 times 10 power negative 3 times 9.81 times sine of 20 plus 3.06 times 10 power negative 3 times 9.81 times cosine of 20 times 9.05. Then the moment is 0.3888, that is approximate 0. Using significant values. In this problem we have the maximum and significant values are 2, and for that I'm going to use 2 significant values. That is 0.39 newtons millimeters, and this moment turns clockwise. The part and C of the problem, of the second problem, and tell us that we need to find the moment about the point O by using the cross product, that is a position vector or air vector, and cross product the force vector. Well, we know that the weight vector is the force vector, and for that we could say that the force vector is equal to the weight vector, that is equal to 3.06 times 10 power negative 3 gravity in terms of y, and this value is negative, and newtons. Well, for the last point, we know that x, to find this vector, we need to find as the point O is in the origin of the Cartesian vector, we need to use the x coordinate and y coordinate to get the point P to the vector and be the vector OP. Well, the coordinates of x, we already know that is equal to, I'm going to check, 12.95 millimeters. Well, now to find the y and coordinate, we need to realize that here we have a triangle in which here we have here is an angle of 20 degrees, therefore this angle is of 70 degrees. So, I'm going to call this part of the triangle, all this part, going to call y1, and this short part I'm going to call y2. So the part y that I need is y1 minus y2. So here we have two ways, two forms to find y1 and y2. To find y1, that is all of this, we need we should notice that this side of the triangle, that is the hypotenuse, is the sum or is equivalent to the sum of the side 3.5 and plus 9.5. So Here we have a triangle. Here we have 70 degrees, and this is 13. And this is y1. So, as you can see, the part y1 is opposite of the angle. Therefore, the part y1 is equal to, well, 13 sine of 70 degrees. 13 sine of 70 degrees. Well, now to find the y2, we did notice that here we have another triangle, another right triangle. And here we have an angle of 20 degrees. And this side, that is the hypotenuse, is equivalent to this side, that is S, that is at the same time 9.05, because they are parallel, and this is 9.05, and this side, and as we can see, is opposite of the angle of 20 degrees, and therefore y2 is equal to 9.05 sine of 20 degrees. Therefore, y is equal to 13 sine of 70 degrees minus 9.05 times sine of 20 degrees. And y is going to be 13 times sine of 70 minus 9.05 sine of 20 degrees. 9.12 millimeters. Then we already have the vector, that is ROP, that is equal to 12.95 y plus 9.12 j millimeters, and the force is just negative 3.06 times 10 power negative 3 times the gravity. And in terms of J and newtons. So now we are going to do the cross product, that is ROP, cross product, the force, that is 12.95, 9.12, cross product 0 in y, and negative 3.06 times 10 power 3 the gravity. And here we have y times y is 0. Y times j is key. So the moment about 0 is 12 multiplied by negative 3.06 is negative 12.95 times 3.06 times 10 over n power negative 3 times the gravity, that is 9.81, and now 9.12 times 0, 0. And terms of J multiplied by terms of J is 0.2. And therefore, and this is in terms of K, therefore the moment is 12.95 times 3.06 times 10 power negative 3 times 9.81, 0.3338, 8 and 7, negative. This is negative in terms of K, newtons millimeters, and the moment is, by using two significant values, negative 0.39 newtons millimeters. We need to solve. Well, this problem says determine the magnitude P at angle of the force at angle alpha equal to 60 degrees, required to lift the wheelbarrow free of the ground at point A. The combined weight of the wheelbarrow and its load is 220 libras, with center of gravity at G. And finally, what is the angle which makes the minimum magnitude of force P? Well, to start and solving this problem, I need to draw the free body diagram and to see clearly and the forces interacting in the problem. I'm going to consider the point A and as the center of the Cartesian plane. Well, here we have the point and the point P. This is an angle of alpha, but alpha is 60 degrees. And we don't have this angle so far. I'm going to call it beta. Since this strange line is equal to this another one, and it follows the same line. This is in the same angle beta. Well, the first thing that I'm going to do is find the angle and that is, as we can see here, we have a triangle. A triangle as following. And 10 plus 12 plus 24 is equal to 36, and I can use the trigonometric function tangent of beta is equal to 14 over 36, and finally the angle is equal to inverse tangent of 14 over 36, that is equal to here is 46. And this angle is 16.92, but I can approximate as 17 degrees. Well, all these angles respect to the x-axis to the force P is 60 plus and 17, that makes 77 degrees. So here we have two reactions. Since we have an angle, here we have two reactions. A reaction AY in up direction, and a reaction AX to left direction. Here we have the weight of the wheelbarrow and its load, and and here we have an angle, it force and can be divided by two components. A component Px and a component Py. But since the force P is the force for only one arm, the woman and all people have two hands to lift the wheelbarrow. So here we have 2P. So in this case, Px is equal to, is going to be 2P cosine of 77, and Py is equal to 2P sine of 77. So now we need to use the following conditions that says that the sum of the forces in X must be 0 and the sum of the forces in Y must be 0. So for the first condition, we need the force Ix that is in left direction. So is minus negative Ix plus Px equal 0. For the forces in Y direction, and I need Ay minus the weight of the wheel and its load, that is 220 libras, plus Py, and that's it. All of this is equal to 0. Well, here we have a point of reaction that I'm going to call by Y. But if the people is not making a force in this point, and this point By is going to have a magnitude for its reaction. So when the people start making effort to lift the wheelbarrow, it point or it this structure is not going to work. So I can consider this variable as 0, because I need to find the force in which the people can lift the wheelbarrow. So for that, I'm not considering this variable. So in this case, we have 2 equations and 3 different variables. So to find one equation, one equation, we need to put the last condition that says that the sum of the moments must be 0. So in this case of in this diagram, I'm going to use the moment at point A, because here are here we have 2 reactions. So the sum of the moments at point A is equal to 10 multiplied by the weight, that is 220, but since this force or this weight is turned in the way of the clock, it is negative. The next moment is 46 times Py, but Py is 2 times P sine of 77, and this is positive because it is turned counterclockwise. And last is 14 px, and this is equal to 0. But the thing of this moment is is negative because it turns clockwise. Well, I'm going to write this expression in terms of P. 46 times 2p sine of 77 minus 14 px, but px is 2p cosine of 77 is equal to 10 times 220, that is 2200. Here I can factorize the variable p, that is 46 times 2 times sine of 77 minus 14 times 2 times cosine of 77, and all of this is equal to 2200, and all of this expression I'm going to calculate 14 times 2 times sine of 77 minus 14 times 2 cosine of 77 is 83.34 equal to 2200, and the value of P is equal to 2200 divided by 83.34, that is 26.39, and using the significant values, P is equal to 26 libras. To find the angle that makes the minimum magnitude for the force P, and I'm going to use the last expression to find it. The last expression was, we need to remember that the angle 77 was found as the angle alpha plus 17 degrees. Well, in the last expression, I'm going to use this term in order to find the angle alpha. The last expression was P times 46 times 2 times sine of 77, that in this case is going to be alpha plus 17 plus 14 times 2 times cosine of alpha plus 17, and all of this is equal to 2200. Well, we can divide all expression between 4 over 4 to simplify it. 550, 4, 23 sine of alpha plus 17 plus 14 times 2 divided by 4 is equal to 7 times cosine of alpha plus 17, and P is equal to 550 over 23 sine of alpha plus 17. Well, this sign is negative. Minus 7 times cosine of alpha plus 17. Well, to find the angle which makes a minimum value for P, I'm going to make a table in which I'm going to give to at the angle of alpha different magnitudes, and then I'm going to calculate the value of P. Well, here we have 10 different values for the angle alpha, and then I'm going to use this expression to put it into the calculator to find the value of P when I use these different angles. This is going to be 550 over 23 sine of 10 plus 17 minus 7 cosine of 10 plus 17 and all of this. I'm not sure about this answer. And the value for when I use the angle at 10 degrees, the value of P is equal to 130.8. So when I use the angle at 20 degrees, the value for P is 66.6. For the angle at 30 is 45.6. For the angle at 40, the magnitude is 35.5. At angle of 50 is 29.8. At 60 degrees is 26.39. for the angle at 50, the value for P is 470. $24.33 at 80 is 23.22. At angle of 90, the value for P is equal to 22.87, and for 95, the value for P is equal to 22.96. As we can see, and the minimum value for P is when the angle is at 90 degrees. So in this case, alpha is 90 degrees, which makes the minimum value for P, that is 22.87.